Hey everybody, my name is Crystal Cochran. I am the Green Infrastructure B&P Specialist for Ferguson in Texas and Louisiana. Today we're going to discuss permeable surfaces and how we can use them to provide a stormwater solution in an urban setting. Rebecca, did you want me to wait a few more minutes or you want me to go ahead?
You can go ahead and start. It looks like we're right at 10 o'clock.
Awesome. Yes, ma'am. Okay, so with the growth of cities comes an increased use of impermeable surfaces. Impermeable surfaces are solid surfaces that do not allow water to flow through, such as concrete, asphalt, stone, or rock. Even the soil that's been super compacted in your yard, right? Like if dinosaurs once roamed it, it's really hard for stormwaters to penetrate that soil. So using these types of materials, it creates a multitude of problems for the waterways. Some of the issues created from using impermeable surfaces in urban settings are increased runoff, pollutants, issues with the local bodies of water, flooding and erosion, and heat island effect. So for increased runoff, urban areas utilizing large amounts of impervious surfaces creates less areas where the water can be absorbed. And then the stormwater picks those up and carries them, right? The debris, TSS, chemicals, bacteria, it carries it all with it to wherever it's going. The pollutants are eventually carried into drainage systems, which go on to pollute larger bodies of water as well. And then the flooding and erosion that comes from these, the impervious surfaces prevent the rainwater from soaking naturally back into the ground, and it forces that rainwater to accumulate, of course, creates flooding. And then heat island effect, concrete, asphalt, and other impermeable surfaces soak up the heat and re-emit it later on. So there's a lot of issues that come along with using these impermeable surfaces. Increasing the amount of impervious material used creates less area where the water is allowed to be absorbed, forcing it to follow along the impermeable surfaces. Stormwater runoff is a leading source of pollutants entering our waterways. According to the U.S. Environmental Protection Agency, about 90% of the surface pollutants are carried by the first 1.5 inches of rainfall. So it doesn't take much rain for it to start picking up those pollutants, nutrients, trash, the soda can that was thrown down from the neighbor's kid, and taking it with it. The water that flows along these surfaces builds really quickly with no way to penetrate the surfaces for which it's falling. In urban areas with rapid increase in impermeable surfaces and urban development, the likelihood of flooding has increased significantly. Similarly, the intensity from which the floodwaters are, it grows too, right? And then it creates property damage in all these areas. So the water that flows along these surfaces builds quickly. It has no way to penetrate the surfaces, and then it has a rapid increase in buildup of the water. The likelihood of flooding has increased significantly in those areas. Similarly, the intensity of flood in urban areas becomes higher with prolonged rainfall. The probability of urban flooding is expected to further increase with the changing climate. Numerous coastal cities are exposed to both urban and coastal floods, whereas the inland cities are only vulnerable to flash floods, river floods, or urban floods. Stormwater runoff can cause stream channel erosion and overland erosion, or both. And then channel erosion occurs in both intermittent and permanent waterways and the streams. So the erosion is significant, and in different ways, it changes different areas. And then there's also sediment deposits. And I'm sorry, you guys, for some reason my computer looks crazy. Channel erosion includes both stream and bank erosion and stream bed erosion. And then the stormwater runoff carries sediment and creates sediment deposits. And the sediment deposits can be found anywhere from mountains to rivers, lakes, deltas, and floodplains. However, it should be noted that while sediment is important for aquatic habitat growth, it can also cause environmental issues if the deposit rates are too high. Pollutants are a problem. 3 of the largest pollutants in an urban runoff are sediment, heavy metals, often from the brake linings on cars, and hydrocarbons. One of the sources of hydrocarbons is the oil that drips into the pavements from the vehicles. And just think like how many cars you passed on the way to work this morning. So that's a lot of pollutants on our roadways that's being picked up by these floodwaters. But the primary contributor is asphalt. Studies have shown that 90 to 95% of the hydrocarbons in urban runoff is from the binder and sealer of asphalt, the pavement, the sealer used for asphalt pavements. Traditional engineering will just move this pollutants from the roadways to drains where it's piped to a centralized location. It just takes these pollutants with them to another site. This type of pollution is significant because unlike the water that goes down your sink drains or your toilets, stormwater is not treated. So it flows directly to the lakes, rivers, and the other bodies of water near you. It creates, oh, and then, okay, so what happens with water with nowhere to go? The streets act as streams, channeling water to our waterways. Because of this, large amounts of water reaches our rivers, lakes, and ponds simultaneously, and it creates flash flooding in those areas. This makes for a need for flood control in these urbanized areas, which is another cost, right? And then the greater frequency and severity for flooding, channel erosion, and the destruction of the aquatic environment associated with these hydrological changes greatly compromise the normal function of our waterways. Vast amounts of water moving through these areas creates severe erosion, which has to be dealt with. So that's another cost for these areas, right? You have to now put a retaining wall up on that creek where you wouldn't have had to before, minus the flooding. Properties such as businesses, homes, and cars are damaged by floodwaters. And again, that's another need, right? Many times businesses are not able to operate because you can't have Papa John's deliver your pizza in the flood, so the businesses are closed and they're losing money. These issues create a need for flood insurance. Many of these things have negative financial impacts on the communities and businesses, homeowners, even the municipalities. Another problem that is stemming from the use of the impermeable surfaces in an urban setting is heat island effect. I'm melting, right? Everyone thinks like the Wizard of Oz's Wicked Witch when we say this, even though she melted from water. But we all think this, like when we're trying to take a nice stroll downtown in July, it's hot, right? It's hotter than when you left your house. And this is real. Heat island effect is real. You are not imagining it. It is actually hotter in those urban areas. Heat islands are urbanized areas that experience higher temperatures than the outlying areas. Structures such as building, roads, and other infrastructure absorb and re-emit the sun's heat more than the natural landscapes, such as like the forest or the pond behind your house. Urban areas where these structures are highly concentrated and greenery is limited become islands of higher temperatures relative to the outlying areas. Daytime temperatures have been shown to be 1 to 7 degrees higher than the outlying areas, and the nighttime temps are on average 2 to 5 degrees higher. Hard surfaces in urban areas, such as the roofs, sidewalks, roads, buildings, and parking lots that we're using to create these urban areas, provide less shade and moisture than the natural landscapes, and therefore contribute to those higher temperatures. Conventional human-made materials used in urban environments, such as pavements or the roofing, tend to reflect less solar energy, and it absorbs and emits more of the sun's heat compared to like the trees, vegetation, your yard, and the other natural surfaces. So a lot of times heat islands build throughout the day and become more pronounced after sunset because everything soaks up that heat and then releases it slowly after night. Heat islands can affect communities and environments quality of life, right? They don't just heat up everything and nothing happens from that. There's this severe like butterfly effect from a lot of these things. So it increases the energy consumption by creating a higher demand to use more air conditioning to cool these buildings, right? It takes a lot more air conditioning. That's why your light bill is way higher in summer than it is in the fall. And then this leads to elevated emissions of greenhouse gases and air pollutants created by keeping up with those increased demands for air conditioning. And this is all made possible by the electric company, which is using, of course, fossil fuels to meet that demand. So heat island effect really leads to a compromised human health and comfort, such as heat stroke, exhaustion, and even impaired water quality. One fish, two fish, red fish, dead fish. We all go to our city parks and see the ponds, rivers, lakes, and a lot of times you will see things like this on the banks. I've never seen this many fish, but we've seen dead fish, and we understand that you're not going to fish out of this water and actually eat it, right? So we want to see what we can do to remedy these situations and enjoy the natural resources that are available to us. So how does this all affect the environment around us? High temperatures of pavement and rooftop surfaces heat up the stormwater runoff, which drains into storms, sewers, and raises water temperatures as it releases into the streams, rivers, ponds, and lakes. So it's not just the streets hot, the streets making the water hot, which in turn make the water bodies that it pours into hotter. This affects all aspects of aquatic life, especially the metabolism and reproduction of many of the aquatic species around you. The rapid temperatures changes in aquatic ecosystem resulting from warm stormwater runoff can be particularly stressful and even fatal to a lot of aquatic life. The impermeable surfaces are more harmful to some species than others. The amphibians, fish, and macroinvertebrates that live in these bodies of water have a really hard time being sustained when, you know, there's pollutants and water heating up being poured into them. It's been shown that streams with more than 10% of impervious surface has far less aquatic life, and those streams can usually only support very tolerant insects. And streams with more than 20% of impervious surface have no chance of sustaining aquatic life. Which is sad, right? We all want to figure out how we can go fishing in our, you know, San Antonio neighborhood park and it not look like this. We want the fish to be able to thrive there so that we can enjoy those resources as well. This is a picture of the water cycle before urbanization. Alterations in the aquatic environment associated with these hydrological changes greatly compromise the normal functioning of our waterways. When the precipitation falls over the land, it follows various routes. Some of it evaporates, returning to the atmosphere, some seeps into the ground, and the remainder becomes surface water, traveling to oceans, lakes, rivers, and streams. Impervious surfaces associated with urbanization alter the natural amount of water that takes each route, changing the water cycle in that area. So when you urbanize an area, the water cycle for that area changes. When urbanization occurs, the table is not adequately recharged, right? So this affects our aquifers as well, which is a huge deal. I happen to live by an aquifer in Texas that is, of course, like all of them, severely protected, and it's a big deal here where the water goes. So because impermeable surfaces send rainwater into storm drains rather than allowing it to percolate down to our aquifers, the groundwater may be used faster than it's recharged. Urbanization causes land surface impermeabilization, which reduces direct infiltration of excess rainfall, but also tends to lower evaporation and to increase and accelerate surface runoff. Pluvial drainage arrangements determine whether there will be a net change in infiltration rate to groundwater, and anything from a major reduction to modest increase is possible. Radical modification to the condition of surface water courses also occurs, and this affects groundwater recharge or discharge. The 3 Ps. So the use of impervious surfaces in an urban setting is creating a triple bottom line effect. It doesn't just affect the planet, it doesn't just affect people, it also affects, you know, their finances. So we're seeing that, you know, people, like I said, when you go to the park, right, or you want to be able to fish in those ponds, or when you're outside and it's way hotter downtown, you don't want to park in your parking garage and walk to your office building. It's really hot and you're sweating before you get there. And then you also see how it affects the profit, right? It costs money. Like I said, it costs money to deal with those erosion. It costs money to deal with the dead fish. It costs money to deal with the floodwaters, to have flood insurance. All of these things cost money as well. So and then the planet, of course, like I said, we want to be able to figure out how we can all be defenders of our natural resources. We want to all save the fish and make everything, you know, we want to protect our resources so that we can all use them properly. So the way that using impervious surfaces is affecting everything, like I said, it's a butterfly effect. We really see it touching more than just one area of our lives. Robert Swan said, the greatest threat to our planet is the belief that someone else will save it. This planet belongs to all of us. We're all in this together, and we all need to start implementing some of the green infrastructure solutions that are available to us to help remedy some of these issues that we're seeing. And we can all help. The municipalities, the engineers, the little boy like down by the stream, right? We all have a place to play in this. But we need roads, right? So now what? How can you have thriving urban areas? I live in Texas. I don't know I know we have people from all over here, but I actually live in an urban area in Texas, and people move here every day, lots of them. So of course, all of these areas are growing, right? We need roads, we need houses, we need schools and buildings to support this growing population. But how do we see not as many issues with this? I know we've covered a lot of issues here today, so we need to find solutions of how we can all live happily together, right? Increasing the number of permeable surfaces, non-compacted soil, and vegetation is a very effective way to remedy these issues. Pervious pavements aid in the reduction of urban heat island effect. Because they are lighter in color and they have an open cell structure, pervious pavements don't just absorb and store the heat and then radiate it back to the environment. This is, what typical asphalt or buildings or the concrete sidewalk would do. The open void structure of the permeable pavement also allows cooler earth temperatures from below to cool the pavement. So it's helping from both directions, which is nice. And then the lighter color of concrete is also beneficial. It's an energy saving standpoint, right? The concrete is reflective. The need for lighting at night is also reduced. And then beyond helping the environment, pervious pavements and pavers are also safer for drivers and pedestrians. It doesn't have water standing on it to spray or puddle. It reduces hydroplaning. In addition to these benefits, it also decreases runoff, carrying pollution, and that encourages groundwater absorption, right? So then you're also helping, like I said, the environment. So you're helping with the flooding and the heat island effect. You're helping all of these things we've covered today just by changing one thing, by adding some alternative surfaces into your designs. And then it also, of course, helps control stormwater, eliminating the need for retention basins or other collection areas. Permeable paving systems are environmentally friendly alternative to traditional paving methods. I've seen them used a lot all around the country now. So I know some of you are already implementing these things, and I know you've already seen some of the positive effects that have come from that. These materials allow water to filter through and into the ground. Some options include permeable pavers, porous concrete pavers, and plastic grids. These options are often laid on a gravel base and allow for a gradual seepage into the ground. So it helps to infiltrate, but also slow the infiltration rate. And then sometimes even with an underdrain or additional storage as our tank. So if you think that you're needing to move a larger amount of water, then we'll be able to infiltrate the ground in that area in whatever amount of time. Then you can add something, like I said, like as an underdrain or some sort of additional storage, such as an R tank system. Essentially, pervious concrete is a structural concrete pavement with a large volume, 15 to 35% of interconnected voids. Like conventional concrete, it's made from a mixture of cement, coarse aggregates, and water. However, it contains little to no sand, which results in a porous open cell structure that water passes through readily. Studies have shown that 90 to 95% of the hydrocarbons in urban runoff are, like I said earlier, from the binder and sealer used in asphalt pavement. So this would, of course, help. Using something like this would help to correct that issue. To address these serious pollution concerns, the EPA and many of the local municipalities, regional groundwater authorities are tightening environmental regulations and requiring more stringent stormwater management practices. Pervious concrete is becoming one of the most viable solutions to these issues. And here are some of the reasons why. Pervious concrete pavement can reduce the amount of untreated runoff discharging into storm sewers. It can directly recharge groundwater so that you can maintain those aquifer levels to help, to replenish them before we're taking too much out of them. It channels more water to tree roots and landscaping so that you can eliminate some of those needs for irrigation. Mitigates pollutants that can contaminate watersheds, and harm sensitive ecosystems. And then it eliminates hydrocarbon pollution, again, from the asphalt pavement sealers. Porous asphalt is another option. High voids in porous asphalt pavements cause water to be filtered through pavement structure into an underlying drainage base, and then the water table, protecting both the subgrade and the pocketbook of the asset owners. Asphalt pavements are made with various types of aggregate materials along with a binder to hold them together. They are designed to let minimal amounts of liquid pass through the system. The design is intended to keep moisture away from the underlying layers, which prevents damage to the entire pavement system. In contrast, the primary function of porous or permeable pavement is to allow water to run rapidly through the surface to a sublayer, which allows general or direct drainage. Porous asphalt pavements are gaining awareness and accepted in the industry as a good solution in areas where there was a drainage issue. This means that they are commonly used for parking lots and other light duty applications. Full depth porous pavement is being used more and more for roadways and as part of efforts to mitigate flooding hazards, reduce hardscape, and improve sustainability. When properly installed, porous asphalt pavements can have a minimum service life of 20 years. You'll see here, this is an example of them pouring water onto this porous asphalt, and it moved 300 gallons of water in 4 minutes. So it has high infiltration rates, and you'll see here, here's a picture of it next to some regular asphalt, and you see it's not holding any water. In addition to the traditional offerings of porous pavements, there's a few alternative options that have been really successful in this space. They fall into 2 categories: formal surfaces, which are permeable pavers and precast forest concrete panels, and then informal surfaces, which are typically grass or gravel fill. Recently, I've seen many people lean toward these options because they have lower maintenance costs and higher conveyance rates. I would define permeable pavers as having a minimum joint width between paving units of at least 1/4 of an inch and with a void space ratio of at least 4%. The void space is calculated by taking the paver area coverage, including the joint space, minus the paver base footprint. The result is the void space available for infiltration, which is shown as a percentage. I believe using a paver footprint is more appropriate because the water will bottleneck as it flows through the footprint area. So it's more important to measure this void space at the paver bottom. A non-permeable paver typically has joint widths between 1/16 and 3/16 of an inch. Most common is probably 1/8 of an inch or slightly less. Some pavers like Unilog do not have spacer bars, so they have less than 1/16 of an inch joint width, just wide enough for a little bit of material to be installed there. A lot of times the material that goes in these, depending on the joint width, is an angular chipstone, which varies again from about 1/16 of an inch to 3/8 of an inch. The way that these pavers go together makes them flexible, so they are rarely subject to any of the like freeze and thaw cycles. They don't get damaged from that. They're like a monolithic flexible structure, so they're able to, they have a little give so that there's not as many issues with that as you would see with like concrete or asphalt. They're great for maintenance as well. If a stone is damaged, you can just pull it out and replace it, right? You don't have to break an entire area of concrete. Permeable paving requires a single size grading of the base material, which provides the voids for rainwater storage. The choice of material is usually a compromise, right? You want it to be stiff enough but permeable and have that extra storage capacity. One of the options I see a lot of times used in this space is the POWERBLOCK system. It is an open joint permeable paver system, and when it's installed properly, it lays flat like pavement, making it ADA compliant. The blocks are made with notches on all of the sides. You can see in the picture on the top. That helps not only to create that space, but it helps with holding it in its place so that the system again acts like a monolithic structure. I know a lot of times people use pavers, they complain about the pavers moving, but the way these are made with the notches and the eye shape helps them to lock into place. And then when installed, the POWERBLOCK has 1,000 inch per hour conveyance rate and low life cycle costs, making it a good contender for this space. POWERBLOCKs are a larger block. They're about 4.5 inches high, and they're able to support H20 and HS25 load ratings. And they're available in a series of colors. So I know there's a lot of like landscape architects that want to use something like this, and that helps them with that. And the color in them is cool because it's mixed in when they're being made, so rather than painted on, which makes it last far longer, and it's able to withstand, you know, pressure washing and things like that. When using permeable pavers such as these, you should consider using just like a runoff row or just doing the parking stalls instead of, you know, there's not a need to do the entire parking lot. You can move that water through just doing like the parking stalls or a run-on row. Open joint pavers maximize conveyance rates and minimize the maintenance needed, and conveyance rates matter. So you can see that even at 50% clogged, these pavers are still moving at 500 inches an hour. So they're still effective in moving the water. Here's some examples of some power block projects. You see, again, they just did the parking stalls, so you wouldn't have to do the entire parking lot, which of course saves some money. Again, this is some power block projects where they were doing just the parking lanes and bike lanes. And you see they're installing it, but you can drive on it, like you're able to actually use them once they're installed that day. Stormcrete is another option that I've seen used successfully in this place. They are precast porous panels, and they're made in a controlled environment, allowing for them to be really high quality. There's a lot of QC that goes into things like these. And they, especially compared to like the pour in place options, they don't have to deal with the weather, and they're not at the mercy of the contractors installing them. So it helps to make the end result a really quality project. Water actually flows through these panels. It has open pores. So it's a little different than the paver systems where the water is flowing around them. Each panel is removable, right? So the same thing, if something happens for whatever reason, you can just replace that panel, so you wouldn't need to damage the area around it. All the panels come with connection ports for easy installation, and they also come with the plugs needed to go into those ports after the install. Again, just as with the pavers, you would be able to drain off the necessary water just using the parking stalls or run-on row. And you'll see here in this alley, again, it's able to support traffic load ratings. You're able to drive on it immediately after install. Here's an example of a Stormcrete project. You see, again, they use just the parking stalls, and not even all of them. You know, you're able to work with the engineers to see how much water you need to use, and you can use some permeable pavements as retrofit applications, so you wouldn't have to tear up the whole parking lot. This is also a Stormcrete project. Again, just use the parking stalls. This is an example of a project where there was a little bird bath in front of this house, and they were able to come in and use Stormcrete panels to take care of that standing water. So with just a few panels, you're able to actually, like I said, take care of the situation without having to damage the whole street or, you know, regrade the whole area. This parking lot had standing water in it after rain events. So they used Stormcrete panels again to come in and take care of that ponding. So you see, this is a good product for, again, retrofit applications. EcoRaster is another option. It's a high performing grass and gravel option. It's made from 100% recycled low density polyethylene. The panels are 13 by 13 and they interlock, making them easy to assemble but really hard to take apart. And again, it allows for the system to act as a monolithic structure. It remains flexible, but they don't separate to where when you have like just a gravel road and you drive over it, you create the rutting and things that you see. So it's able to handle expansion as well. The way that they are installed, again, is flat. So the EcoRaster is ADA compliant and it comes with a 20-year warranty. You'll see in the pictures that there's a fire truck driving on it. You'll see how it took care of the ponding, and then you see this nice lady in her little walker with the wheels able to make it over it. So it addresses a lot of the concerns that come along with using some of these solutions. EcoRaster also has a permeable paver option that works really well. The blocks can be made from recycled rubber or concrete, and they're available in a series of colors. The plastic frame has drainage channel around it on all sides, and it sits on a stone base. So it also works well with expanded storage systems, such as like an R-tank system. And there are, again, a lot of areas where you can maybe consider combining pavement types in case you're just wanting to go in and use these as like a retrofit application or something like that. You know, you're having drainage issues somewhere, but you don't want to go in and redo the whole parking lot or the whole street. Here are some examples of a project where, again, they combined the pavement types. They wanted to do some grass and some gravel options. And these would work really well for like rodeo grounds or something like that, where you have parking intermittently, but not every day. You can also enhance the storage under these permeable paver systems. So you'll see here that there have been R tanks placed under. This is a storm create project, a power block project, and then you'll see the parking lot down here that has an R tank system underneath. So there's a lot of options that you can do to create the solution you're looking for. Here's another example. This is a cross section of a permeable paver project where we used Belgard pavers and incorporated it with an engineered media. So if you're looking to treat the water while you're moving it, you can do that with these permeable pavers. All right, let's talk about maintenance. That's everyone's question, right? How do you actually take care of them, especially when it's new to you? If you're in an area where you're not implementing green infrastructure a lot, it always comes back to maintenance. You are always welcome to follow ASTM C1701 guidelines for testing of infiltration rates, determine if your site needs maintenance. But, you know, there are some obvious signs, right? Like if you just go out and inspect the sites pretty regularly, then you will notice if there is water ponding. Of course, it's best to get on a maintenance schedule. This, of course, depends on site conditions, right? If you live in an area with lots of trees, or it's a small permeable area that is responsible for moving the water off of a pretty significant watershed, then it will obviously require maintenance more frequently than an area with little traffic, little rainfall, no debris, no trees, no grass around it. Some are set up annually, biannually, or even quarterly on maintenance schedules. But if you see ponding on your permeable surfaces, then obviously it's time for some maintenance. Same thing. This is an example. This is a Storm Creek project that has water sitting on it. It should not have water sitting on it. So it's a pretty clear indicator that it's time for some maintenance, right? Same thing. There's a lot of debris on the surface, and there are gaps around them that are being filled with debris, sediment, grass growing in them. It's a need to be maintained. And this is something that you can see right here, the trees obviously played a factor in this. So while this is still a great place to put these pavers, if you are going to implement a porous system or a permeable paver system, or any of these systems that we've talked about today, in an area where there are trees that are dropping a lot of debris or something like that, then you need to expect that they will have to be maintained a little more frequently than an area without them. And the way that we would do that typically is with a vac truck, or even just a vac head attachment for some of those trucks. So the maintenance on porous pavement is simple, which of course keeps the cost of these systems down long term, right? It makes them a feasible solution to some of the situations that we've talked about today. You see here, very simple walk behind system, cleaning it up. That's it. Thank you guys so much for joining me today for Stormwater Awareness Week. Hopefully you guys will take what you learned today and start implementing it in some more pervious pavements into your designs. My contact information is on the screen. Please take it down and feel free to reach out to me in the future if you have any questions. And I know Rebecca said she was going to be awesome enough to look at the chat.
Yeah, so we have some questions. So the first one is from Tasha. And she asks, what is the initial cost and maintenance for porous asphalt versus non-porous asphalt?
Oh, good question. Most recently, I honestly don't have a good answer for you on non-porous asphalt, and I'll be happy to look that up for you. I mean, I would say it's a street sweeper, right? And typically the street sweeper and the vac truck both come out in 4-hour shifts, right? You don't get it for 30 minutes. So it would be, I would say, roughly the same cost, whether you're bringing out a vac truck or you're bringing out a street sweeper. You still have to clean them off. I mean, of course, asphalt doesn't, I guess, require it. The water is still going to move down it. It's just picking up debris with it. So I think it's really just a matter of what solution you're trying to provide in that space. But I've seen most recently about $1.50 a square foot as far as the maintenance cost for the porous asphalt.
Awesome. And then we have a question from Aaron. who says, the most of the objections I have heard from people that do not want to utilize porous pavement is that it degrades over a relatively short amount of time, leading to higher maintenance costs. Could you address that objection?
Yes. Do you mean degrades, like the product itself will not work anymore, or do you mean that it's just needing to be maintained?
Aaron, do you want to clarify that in the chat?
Or it's okay. Let me try to address both. I don't, of course, there probably are products that don't perform as well as others. I have seen some products that maybe are a little more susceptible to having issues, right? Especially if you're looking at a product that is like maybe pour in place porous concrete. It is really just dependent on everything, right? The environment has to be perfect to install it. The installers, it would be great if they knew what they were doing when they were installing it. So there's a lot of factors that go into making it perform well. I would say if a lot of those things aren't met, then it would be easier for it to start degrading, like you said, quicker. If you chose an option that was a little more resilient and easier to install, wasn't as like most of the solutions that I showed today, besides the pour in place solutions, are like minus a hurricane, you can install them and they will still be okay. So that I would say it probably depends on that. But then as far as maintenance, again, it will depend, right? I have been on site on projects that have been in the ground for quite some time, years, and have not ever been maintained. They should have been maintained. They have not been maintained, and they're still able to move the water off of the surface. So like I said, a lot of the solutions now, even at 50% clogged, are still moving water 500 inches an hour. If that did not answer your question, please feel free to let me know, clarify some, and I'll be happy to see what I can do.
Perfect. Then we have a comment from Gail, who said, the power block reminds me of the extremely common infrastructure in Europe. For example, in the Netherlands, I saw this in all the Dutch cities, towns, and villages. It's pretty cool.
That is cool. I will have to look at that. Thank you for sharing that.
And then we have a question. Can you provide costs for these various systems? Cost generally limits use for these for residential purposes.
Forgive me, are you saying cost?
Yeah, cost.
Yes, I'm sorry. Okay, I see the question. Mostly. Oh no, that's not.
It was sent directly to me, so I could put
okay,
it.
I was gonna say I don't see it, but can you just repeat it? Are you saying? Oh, okay.
There we go.
Provide cost for these systems. Cost generally limits. Yes, yes, definitely for residential purposes. I agree. I will say, depending on of course, what product, what system, what area you're looking at, what area you're in. A lot of these products, like the Stormcrete is made in the northeast part of the United States. So if you're having to freight that to somewhere else, then we probably need to, it would depend where you're at. But yes, I'll be happy to provide you costs for, you just want costs for all of them?
You can comment in the chat if you want to respond to that.
I'm sorry. Yes, I'll be happy to try to get some costs. I know a lot of times you're right. They do cost a little bit more upfront. What I would say to that is that as far as I've seen, it's less maintenance, and they're more efficient, right? At moving the water, they're solving a problem. So sometimes it's worth the cost. And I know a lot of times, I know you're speaking to a residential area, so that's a little harder, but especially in areas that aren't residential, a lot of times it comes along with funding that was made available specifically for those purposes.
So it sounds like if you want a cost estimate, contact Crystal and she can work you through that.
What I can do for you. Yes, ma'am.
We have a question from John. Is there a maximum slope in the design or installation?
Yes, of course. It would depend on which product, but yes, of course, I'm sure each one would vary. Obviously, I would not use like the PowerBlock porous pavement to do like a vertical retaining wall, but you can put them on somewhat of a sloped surface, right? All roads are not just flat. But if you're talking like, I don't know how steep of a slope you're talking about, but if you're looking for like a green solution for a retaining wall or something like that, you'd be welcome to reach out to me. There are a lot of solutions for that space that are still green.
Awesome. And we have a question from Aaron. So would you say that porous pavement durability comes down to in large part of how it is initially installed?
Absolutely. I think installation makes a big difference on everything. The product itself will still work, right? I have a Stormcrete sample, and if I go throw my water hose on it on the driveway, it's still going to have water going through it. But for long-term use, you want them to be installed properly. A lot of times, I know these products, and I would say probably with all newer products like this that are new to a space, the manufacturer or whoever you're looking at getting it from will have a representative, I would think, come out to the site. I know Ferguson does have someone come out to the site to make sure they're installed properly, until that's like a trusted contractor, I guess. That way you can avoid any issues that you might see in the future. Yes, installation matters.
Awesome. Well, it looks like that is it for the chat questions. If you have any more questions, you can just put them in the chat and we will love to look at those for you. Yeah. And in the meantime, if you missed any portion of this workshop or any of the other workshops, you can see the recording of it on our website. This one will be up on the website in about 24 to 48 hours. So you can head over to stormwaterawareness.org and watch the recorded versions of the workshops or sign up for the remaining workshops of this week. You can also watch our keynote videos, which are on the page. We have one from Lost Landing, and we have one from the Carquinez Strait in the Bay Area, when it's talking about where the river meets the sea and the unique challenges and successes that are in those areas. So you can watch those from our website. But thank you, Crystal, for presenting today. And thank you everyone for attending. And we hope you enjoy the rest of Stormwater Awareness Week.
Yes, ma'am. Thank you so much for having me. Thanks, everybody.